For most of human history, Mars was nothing more than a faint red star wandering across the night sky, a mysterious point of light that seemed to move against the backdrop of constellations. Ancient astronomers chronicled its unpredictable path with awe, weaving it into tales of war, destiny, and cosmic change. Even as telescopes sharpened humanity's vision, the truth of Mars remained stubbornly elusive. Theories filled the gap: vast canals, dying civilizations, deserts of strange vegetation. It wasn't until the dawn of the space age that Mars slowly transformed from a story of imagination into a destination grounded in science and engineering. Today, Mars is more than a distant world. It is a frontier, a scientific laboratory, a proving ground for new technologies, a geopolitical stage, and the next great target of both national and private ambition. No mission demonstrated this shift more dramatically than China's Tianwen-1. In one bold campaign, China delivered an orbiter, a lander, and a rover to the Martian surface, signaling not just technological advancement, but the arrival of a new era in the race to Mars. The competition is no longer led by one or two nations. It is a global pursuit, shaped by shared curiosity and strategic rivalry. Yet the story of Mars exploration truly begins decades earlier, during what scientists often call the Viking moment. In 1976, NASA's Viking 1 and Viking 2 missions became the first U.S. spacecraft to land safely on Mars and return panoramic images of the surface. These missions carried the first life detection experiments ever sent to another planet, and although the results were inconclusive, they reshaped scientific thought. Viking taught us that Mars is not a simple world, and searching for life requires patience, creativity, and the humility to accept ambiguity. The cameras on those landers revealed wind-scoured plains, scattered rocks, and skies tinted with dust, images that gave humanity its first real sense of what it might feel like to stand on the surface of another planet. But Mars is not just intriguing, it is difficult. Every mission to the Red Planet is a battle against its hostile environment and contradictory physics. The atmosphere is too thin to slow a heavy spacecraft, yet thick enough to cause intense heating during entry. Surface pressure is less than 1% of Earth's. Temperatures plunge far below freezing. Dust coats every surface, cripples solar panels, and can swallow the entire planet in storms that last for weeks. Landing successfully on Mars requires threading a needle with absolute precision. Many missions have failed. Every success is a triumph of engineering and endurance. The modern era of Mars exploration truly opened with a handful of pioneering spacecraft, the Mariner missions. In 1965, Mariner 4 flew past Mars and returned the first close-up images ever captured. The world waited as the first grainy photographs, printed line by line, revealing a cratered surface that shattered romantic ideas of canals or lush vegetation. Mariner 6 and 7 added more detail, and then Mariner 9 accomplished something unprecedented. It became the first spacecraft to enter orbit around another planet. When Mariner 9 arrived, a global dust storm blanketed Mars. Only after the storm cleared did the spacecraft uncover the true face of the planet. Towering volcanoes like Olympus Mons, canyon systems like Valles Marineris, and ancient channels carved by flowing water. Mariner 9 did more than capture images. It changed the way humanity understood Mars forever. From there, the next great leap came with the Viking landers. They brought not just cameras, but full laboratories designed to analyze the soil for signs of life. The results sparked debates that continue to this day. One experiment suggested possible signs of biological activity, while others pointed to purely chemical reactions. The ambiguity taught scientists a sobering truth. Detecting life is far more complex than simply landing a spacecraft and taking a sample. But Viking's discoveries, its high-resolution images, its weather data, and its biological experiments became a foundation for everything that followed. Decades passed before the next major advance in surface exploration arrived. In 1997, NASA's Pathfinder mission touched down with a small rover named Sojourner. It was little more than a microwave-sized robot on 6 wheels, but it made history as the first rover to operate on another planet. Sojourner proved that mobility was possible, that a rover could maneuver around rocks, analyze soil, and send back panoramic views. That small machine changed the philosophy of Mars exploration forever. Instead of placing static landers in isolated spots, scientists could now imagine missions that drove across the landscape, searching for geological clues and following the story of water. The next chapter began in 2004, when NASA landed 2 twin rovers, Spirit and Opportunity. They were designed to last just 90 days. Instead, Spirit survived for 6 years, and Opportunity for nearly 15. These 2 rovers transformed our understanding of Mars. Opportunity landed in a region called Meridiani Planium and quickly found evidence of ancient water, hematite spheres nicknamed blueberries, layered rocks shaped by long-lasting water, and minerals that form only in wet environments. Spirit, working in Dusiv Crater, uncovered signs of volcanic activity and ancient hot springs. Together, the rovers established a powerful conclusion. Mars was once a world shaped by water. Not just brief floods, but long-lasting, stable environments where water pooled, flowed, and evaporated. In other words, environments potentially suitable for life. As rover technology and scientific goals grew, engineers needed new landing techniques. The breakthrough came with the arrival of Curiosity in 2012. Weighing nearly a ton, Curiosity was far too heavy for airbags or traditional landing systems. NASA engineers invented an audacious new method known as the sky crane. During the final moments of descent, a rocket-powered stage hovered above the surface and gently lowered the rover on a set of cables. It was one of the boldest engineering feats in space history. The technique worked so well that the same system would later deliver the Perseverance rover. Curiosity set down inside Gale Crater, where it found clear evidence of ancient lakes, clay-rich sediments, and organic molecules preserved in 3-billion-year-old rocks. It measured methane in the atmosphere, its source still a mystery, and it confirmed something scientists had long suspected. Ancient Mars was habitable. Whether life ever existed there remains unknown, but the conditions were undeniably present. The next leap came with Perseverance, which landed on February 18, 2021. Its mission is one of the most ambitious in planetary history. Perseverance is exploring Jezero Crater, a preserved river delta that may hold some of the best evidence of past life on Mars. The rover is collecting rock cores, sealing them in titanium tubes, and leaving them for a future mission to retrieve. These samples may one day return to Earth, where laboratories can analyze them with equipment far more advanced than anything a rover can carry. Perseverance brought with it 2 groundbreaking technologies. The first was a small helicopter named Ingenuity. No one knew whether powered flight was possible in the thin Martian atmosphere, but shortly after landing, Ingenuity rose into the sky, making the first controlled flight on another planet. What began as a short demonstration became a long-term success, with dozens of flights that changed how scientists think about off-world exploration. The second technology was MOXIE, a device designed to turn Martian carbon dioxide into oxygen. It proved that future astronauts could potentially produce breathable air and even rocket fuel using local resources. This concept, known as in situ resource utilization, is a cornerstone of future human missions. While landers and rovers tell the story of the surface, orbiters provide the global context. High-resolution imagers, radar instruments, and climate sensors have mapped Mars in extraordinary detail. NASA's Mars Reconnaissance Orbiter tracks dust storms and captures images sharp enough to reveal the tracks left by rovers. ESA's Mars Express